Hello everyone, a very good morning to all. Hope you are ready for today's problem. Today we have a problem from 2015's question paper. A right circular cone, base diameter 50 mm, height 50 mm, is placed with its base resting centrally on the top rectangular face of a horizontal triangular prism. Side of the triangle 40 mm, length of the prism 70 mm, keeping triangular faces of the prism parallel to VP. Draw isometric projection of the combination of solids. Show the axis of each solid and indicate the direction of viewing. Here, the first solid, triangular prism is horizontal. Horizontal means axis of the prism is parallel to HP, and keeping triangular faces of the prism parallel to VP. So these two triangular faces, opposite triangular faces, are parallel to VP. If you assume this board has vertical plane, then these two faces are parallel to board or parallel to VP. Also, on the top rectangular face, it means on top for this prism, on the top it has a rectangular face. So this is the final position of this solid. So the solid is resting on its generator on the ground on HP. Two opposite triangular faces are parallel to VP, and on top rectangular face is horizontal. Then second solid, cone is placed with its base resting centrally on the top rectangular face. So the cone is resting on its circular base on the top rectangular face of the prism. So this is the final combination. These are final positions of these two solids. Centrally means center of the cone. Center of the cone will coincide with the center of this upper rectangular face of the prism. So this is final combination. In construction, we will start from the first solid. We will project this prism, and then we will place this cone on the upper rectangular face. So we will start from vertical plane. We will project the vertical triangular faces here. Then we will complete the projection of triangular prism, and then we will project circular base. Now for projecting triangular prism or triangular faces of this prism, we have to draw its helping figure. So drawing a helping figure of triangle or drawing a regular triangle of size 40, we have to take ISO 40 for the construction work. So we have to construct a regular triangle of size ISO 40, and then we have to enclose this triangle inside a box, inside a rectangular box. Side is 40, the side is 40. Now we have to draw lines parallel to first base, and perpendicular to that base, passing through all corners of the triangle. So these are 3 corners of triangle, and these are 4 corners of the helping box. Next, we have to locate center of the triangle. So for locating center, drawing lines from midpoint to opposite corner, common intersection point is the center. Okay. Drawing lines parallel to first base side for location or for center representation. Now these are dimensions of helping figure. 40 y and distance of center from the base side is y dash, location or distance from the center. Next, from center we have to draw center lines parallel to first and second base of, you can say, center lines are lines parallel and perpendicular to first base side. So this is complete helping figure along with the center. Now the prism is resting on its generator like this. It means we have to project this triangular face along vertical plane of isoset. So we have to mark this length 40 along first iso axis and y. This is y. This is y. This one is y dash and y along vertical axis. So marking limits of 40 and y along first iso axis. So along first iso axis we have to mark 40 and y along vertical iso axis. Vertical iso axis means parallel to third iso axis or parallel to vertical axis. So this is the projection of helping figure. Now from all four corners of this helping figure we have to mark limits of axis, and axis is 70. So along second iso axis we have to mark limits of 70, or simply we have to draw lines parallel to second iso axis, and the length of each line will be equal to ISO 70 and parallel to second iso axis from last corner, length is equals to ISO 70. So these are four limits okay. Now joining these corners parallel to first and parallel to vertical axis, we'll get the second face of helping figure. Next we have to mark all corners. So here these two top corners are final corners of triangle, and the third corner is say C, A, B and C. So from this corner distance is this much. Okay, now joining all corners of the triangular prism. Okay, this is complete projection of first solid triangular prism, which is resting on its generator, axis parallel to HP and perpendicular to VP, and both triangular faces are parallel to VP. Now second solid cone is resting on its circular base on its center. On its center means on the upper face of this prism and centrally. So first is we have to find the center of this upper rectangular face. So by setting all four sides of upper face, and then drawing lines parallel to extreme sides or parallel to first and second, center line or first and second iso axis. So this is the center this is final center line. So this is the center of the top horizontal rectangular face. So from this point we have to start construction work of the base circle, and we know that for projecting a base we have to draw a helping figure, and size of the helping figure or helping square for circular base is always equals to the dia of the circle or circular base. So from the center we have to mark limits of, from this point we have to mark limits of ISO half of 50, 25 along all four lines or along both lines. So marking limits of ISO 25 along this line, ISO 25 and ISO 25, and along this line also ISO 25 and ISO 25. So these are four limits or 4 points. Now from all 4 points you have to draw lines parallel to first and second ISO axis. Lines parallel to first and second ISO axis. Right. Please don't do this. I am doing it. To show the helping figure okay. So this is my final helping figure, helping square. Now we have to apply 4 cent method or any other method, but 4 cent method is best method. So applying 4 cent method, first step is we have to mark all 4 midpoints, first midpoint, second midpoint, third midpoint and fourth midpoint. Then we have to join diagonally opposite corners. Which one? Larger or longer one. Next step, from midpoint to opposite corner, midpoint to opposite corner, midpoint to opposite corner. Now we have all 4 centers, first center, second center, third and fourth. From all 4 centers, from first center, this is first center and this much is first radius, first part, second center and second radius, second part, third center, this is third radius, last fourth center and fourth radius. So this is the base, circular base of the cone. Next, solid axis. From the center of the rectangular face or center of the circular base, we have to draw a line perpendicular to third or vertical ISO axis for a length of ISO 50. So this height or length is ISO 50. Now we have apex point. In the last step, we have to show all visible sides and generators. So for cone, these extreme generators are visible generators, and frontal portion of circular base will be visible. So from apex to extreme generator, these are visible generators, and then front curved portion of the circular base is visible. Next, for prism, these are visible. Yes, these are visible edges of, from this point, these are visible sides and edges of prism. front triangular base, okay. Next we have to show center lines and centers. Center lines and centers for both solids. Okay. For locating center of this triangular base, this is the distance from upper base. This is the distance from upper base. And from midpoint to the last corner. From midpoint of this side to the last corner. This is the corner. This is center of rear base, and this is center of front base. Last solid axis of the prism. Axis is parallel to HP and perpendicular to VP, and axis of the cone is perpendicular to HP. And for combination, these two axes are intersecting axis. Last, dimensioning. For dimensioning, what to do? Okay, extend lines parallel to second isometric axis, and dimensioning line parallel to solid axis. 50 diameter of circular base, dia is 50. Size or side of triangular base or triangle, this is 40. So we'll extend this line like this, and we'll show the side and last axis or length of the prism. Length of the prism is 70. Next, direction of viewing or direction of observation. This is the direction of observation. And then labeling or naming. So this is all from my side. Please draw this problem on your sheet. Indicate direction of viewing, direction of observation, do all dimensioning, write headings of these two figures, and if you have any problem regarding this question or in any other topic in engineering graphics, please write your comments in the comment section. Thank you.